Rockets are like dragons, but backward. Just as a dragon makes explosive flames, a chemical rocket engine makes explosions that can bring people and robots to orbit and beyond Earth. So what is a rocket? A rocket is a crew or some cargo atop computers, which rest on massive propellant tanks and engines that spew tons of hot gas. Why do we shoot out so much gas? Well, when a rocket forces out gases, they force our rocket up. This shows Newton's third law of motion, which says that every action force has a reaction force that is equal in magnitude and opposite in direction. If I'm on roller skates and throw my bag to the right as my action force, my bag exerts a reaction force of the same magnitude on me to the left. Likewise, our rocket shoots super hot gases down to feel an upward force we call thrust. How do we make enough thrust to go fast enough to reach space? Our engine uses combustion, a chemical reaction in which we combine and ignite fuel and oxidizer to create substances, heat, and light. In other words, burning things. Our propellant is made of a liquid hydrogen fuel and a liquid oxygen oxidizer, which combine to create water and energy. Wait, aren't hydrogen and oxygen usually gases? Yes, but their gaseous forms are not dense, meaning their far apart molecules take up lots of space. We cool hydrogen and oxygen gas to their denser liquid forms to stuff more propellant into our tanks. At minus 423 degrees Fahrenheit, our liquid hydrogen is closer to absolute zero, the coldest temperature possible, than it is to ice cream. Now, at our engine, our pumps force propellant into our combustion chamber, where they ignite to make gases that can reach up to 6,000 degrees Fahrenheit. That's more than 17 times hotter than the oven temperature for baking most cookies. Then, our nozzle accelerates the gases out of our rocket up to 13 times the speed of sound to generate a lot of thrust. In short, we use super cold liquids to shoot out super hot gases. Do you know what's even cooler? Our liquid hydrogen and liquid oxygen mix is the most efficient commonly used rocket propellant, giving us the most thrust for every bit of propellant we burn. Wait, if space has no air or oxygen, can we keep powering our rocket with combustion? Yes, we can keep going because we've brought our fuel and oxidizer with us. Also, chemical rocket engines are more efficient in space because there's no air to slow down our gases from escaping our rocket. Once we use the propellant in our first stage, we discard it, and our second stage continues to orbit. After we escape Earth's gravitational pull, we can explore space. Oh, and hear this. If we go to the Moon or Mars, scientists think we can harvest hydrogen and oxygen from lunar and Martian water to make propellant. It's like going on a long road trip to a new restaurant that happens to serve your favorite meal. Okay, so why do chemical rocket engines matter? Well, chemical rockets epitomize our creativity, collaboration, and care to explore beyond our planet. Together, we can reach new heights.